Lesson 32, quotient theorem for square roots, congruency, and congruent triangles. Let's first of all talk about the quotient theorem for square roots. All right, we know quotient is the answer to a division problem. All right, and we know what a square root is, so we are dealing with division and square roots. Now, the form of division that we're going to be dealing with is fractions. Okay, remember fractions are just another way to write a division problem. That fraction bar means to divide. Alright, so for example, we're just going to start with an example and talk about a couple things as we go through. We've got the square root of 3/7. Alright, so we are square rooting the fraction 3/7. When we have the quotient theorem for square roots, we write the numerator and denominator as separate square roots Right, and then remember from previous lessons, we can't have a square root in the denominator. So we simplify by rationalizing the denominator. We're getting rid of that radical. Alright, so we write the numerator and denominator as separate square roots. So instead of the square root of 3/7, we have the square root of 3 over the square root of 7. They equal the same thing. Okay, we're just separating them out. Now we know that we can't have a square root in the denominator, so we rationalize it. And if you remember from previous lessons, we rationalize it by multiplying both the numerator and the denominator by whatever root is in the denominator. Alright, so the square root of 3 times the square root of 7 is the square root of 21. And the square root of 7 times the square root of 7 is the square root of 49. Well, that now gives us a perfect square, and it simplifies to root 21 over 7. Alright, so we write the numerator and denominator as separate square roots, and then simplify by rationalizing the denominator. Alright, we're going to add something to it. Alright, in our next example, we have the square root of 2/5 plus the square root of 5/2. Alright? Now, we need to first of all use our quotient theorem for square roots and separate these. Alright? So we rewrite them with the square roots in the numerator and denominator. We have the square root of 2 over root 5 plus root 5 over root 2. Okay, now we know we can't have roots in the denominator, so let's rationalize each one. Let's start with the first fraction, root 2 over root 5. Right, we want to get rid of the root in the denominator, so we're going to multiply both by root 5. Right, square root of 2 times the square root of 5 gives us root 10, and root 5 times root 5 is the square root of 25, which is 5. Right, so we have 10/5. Root 10 over 5 is our first fraction. Let's rationalize the second fraction. We have root 5 over root 2. To rationalize it, we're going to multiply both by root 2. Root 5 times root 2 is root 10. Root 2 times root 2 is the square root of 4, which is 2. Alright, so our second fraction is root 10 over 2. Alright, now we know that when we're adding fractions, we have to find a common denominator. Alright, so we are going to find a common denominator between 5 and 2. Common denominator is 10. Alright, now keep in mind, the coefficients for both of these is 1. And we're going to treat the roots like a variable. Alright, so 5 times what gave me 10? Well, that's 2. So we're going to do 2 times 1, which gives me 2, and we bring over root 10. Right, 2 times what gave me 10? That was 5. So we're going to do 1 times 5, which is 5. Again, treat the root like a variable and bring it over, root 10. So now we have fractions with common denominators. We have the same root, so we just add the coefficients. 2 plus 5 is 7. Bring over our root 10, and it's over our common denominator of 10. All right, so we have simplified that root. All right, so square root of 2 plus square root of 5, square root of 2 fifths plus the square root of 5 halves simplified to 7 root 10 over 10. All right, let's try another one. We have 3 square roots of 3/7 minus 5 square roots of 3/7. All right, first of all, we write numerator and denominator as separate radicals. So we have 3 square roots of 3 over square root of 7 minus 5 square root of 3 over square root of 7. Okay, now, we can't have a radical in the denominator, so we need to rationalize. Now, lucky for us, these denominators are the same. So we just have to multiply both by root 7, and that will take care of both fractions at once. If we rationalize, we get root 21 over 7. All right, so our new problem looks like this. We have 3 root 21 over 7. We keep our coefficient minus 5 root 21 over 7. Okay, again, keeping the coefficient. We already have common denominators. All right, so we're going to keep the denominator. We're going to keep the radical because they're both the same. And we subtract our coefficients. 3 minus 5 is negative 2. And there we have it simplified. All right, this next one, I want you to try on your own. We have 2 square root of 2/7 minus 5 square root of 7 halves. Okay? You want to write each numerator and denominator as separate square roots, rationalize the denominator, and then add or subtract by finding a common denominator. All right, go ahead and try that one. Pause the video if you need to, and hit play when you're ready to move on. All right, the next thing that we're going to talk about is congruency. All right, when we're talking about congruency, we're talking geometry. All right, in algebra, we have things that are equal. In geometry, we have things that are congruent. All right, only numbers can be equal, so we use congruent to mean geometrically equal. All right, only numbers can be equal. So we use congruent to mean geometrically equal. All right, on the board, I have 2 similar triangles, all right? But we're going to determine if they are congruent. Congruent triangles have a scale factor of 1, meaning they have equal sides. We're going to use that information to solve for x and for p. All right? Now, if you will notice, in these triangles, the left-hand side is 6, or the right-hand side is 6 for both of them. All right, so since 6 equals 6, their scale factors are 1, meaning all of their sides are congruent. They are geometrically equal. So we can also say that 6x plus 2 is congruent to 12x minus 4. All right, so we're going to use an equation to write that. 6x plus 2 is equal to 12x minus 4. All right? Now we have an equation in which we can solve for x. Okay, so we're going to solve for x by subtracting 6x from both sides and by adding 4 to both sides. And we get 6 is equal to 6x which means that x is equal to 1. All right, so we have solved for x. If we plug it back in, we're going to figure that both of these sides are equal. 6 times 1 is 6, plus 2 is 8. 12 times 1 is 12 minus 4, which is 8. Okay, so you will see that these sides are congruent. If we substitute x in for 1 on this side, 4 times 1 is 4, plus 1, which is 5, which means that p equals 5. And that is congruency. Make sure that you have the example for quotient theorem done, and we will check it when we come back into class.